Hey, so welcome back, and this is another daily LeetCode problem. So today it was called longest palindromic subsequence, and it's a medium level question. And so this is like a different one where I'm actually just going to already have the code written out, and I also have some printing statements. And it's just for me because this one was just a harder problem. It's a two-dimensional dynamic programming problem, so it wasn't very intuitive for me. Initially, I thought it was like a backtracking problem where you kind of keep track of 2 pointers and do this uh, in a brute force manner, but it seems like you actually can do it using dynamic programming. So essentially what you're going to do, and I have all these print statements showing you the two-dimensional grid that you're going to make, is in the final case, this 2D array is going to look like this, where you have these letters, B, B, A, B. And just to explain the problem, I guess I should quickly. You will have a given string assigned to you, and you want to see what the longest palindromic subsequence is for it. And a subsequence is just, say you're given a sequence, and you want to find out, okay, what is the longest palindrome that you can have in here? And palindrome's just when reading it from left to right, it's like the same. So whether you read it forwards or backwards, you'll read it the same word. But a subsequence is like you can actually just take any of these numbers and you can remove some and you can keep some, but you just have to keep the ordering. So in this case, we could just remove A, and that would give us the longest subsequence, B, 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 B. And that's fine because we're not changing the ordering. We're just keeping or removing something. So that's a subsequence. Okay, and so all that we're gonna do is say, okay, why don't we make a two-dimensional grid from this, and we're going to put the word like this, just like how it is, but then we're also going to spell this word downward. So this is B, then B, then B, then A, then B. Okay? And so all that you're going to want to say is, okay, given these two strings then, we're going to build it kind of in this direction where we go from left to right, and then left to right, and then just keep going like this, okay? So we're going to start from the right, and then we're going to go out, and then in, out, in, out, in. Okay, and that's what these two for loops are doing, is we're just kind of maintaining this iteration here, okay? And so that's how we do that. And so what this kind of represents is we'll be comparing, in this case, this B with this B, and we'll say, okay, what's the longest palindrome here? Well, that's 1 because they have a length of 1. And then we're going to compare A with A here, right? And so we're going to compare this row to this column, and AA, well, that's the longest palindrome there is 1. All right, and that covers this case here where initially we just set it to 1. And so from there, we're going to be like, okay, now we have to take this, which that's going to be comparing, that'll be comparing A to B, basically. So we have A here, and we're comparing A and B. Not just A and B, but this sequence here, which is A and B. All right, and so the longest palindrome from comparing A and B will just be 1. And you get that by just saying, okay, you've now entered this for loop, like we've already done this logic here to get that 1. We've entered this for loop and we say, okay, if A does not equal B, because we're at the B column, then let's do this logic, otherwise we do this. And since A doesn't equal B here, then we're just going to take the maximum of what's below it and what's to the right of it. And the reason we're doing that is because, well, when we get to here, we realize that with the sequence A and B, and we're comparing A with it here, we already know what the longest or palindrome for A and A is, and we already know what the longest palindrome for B and B is, and those are both 1, right? But when we're saying, okay, what is then the longest palindrome for both of these? Because A and B don't match, like these aren't parallel to each other, then you just have to grab one of these, whichever one's maximum, and they're both 1 in this case, so we just set it to 1. Okay, it might be hard to wrap your head around, but maybe the second example will help you because it's a bit longer. And so then we move on and we go for this one, and we say, okay, what is comparing, and once again, this is B, 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 A, then B. So now we're comparing B to B, and so that's 1. We initially just set it to 1. And then we compare, okay, when we look at B and A, we've now entered this for loop, and we say, okay, at B and A, this subsequence here, since B, we have a B here, does not equal A, then you want to compare, okay, below whatever's below it and to the left of it, take the maximum, and that would be the comparison of BB and AA. And so that would just be 1. The maximum of these two is 1. And so you set 1 here. All right, and so then you move on, and so then you're at this iteration where you see, okay, now we're comparing B with B, A, and B. And then you see, okay, these do match. B here on this row matches with this B column, right? These two. And so then you want to say, okay, you actually handle this case where they are equal to each other. And in that case, you add a 2 to whatever's in the diagonal of it. You don't take the maximum of what's to the left and what's below it, but you take the diagonal value, which is 1, and then you add 2 to it, okay? And so the reason behind this is the diagonal value of this BAB versus B here is actually AA. And AA represents what's in the middle. So whenever you take the diagonal of like this subsequence, you're actually grabbing what's the current maximum of its diagonal. So say in this case it was actually more like this, and say we pre-computed that its diagonal was 3. And so when we're calculating this cell, since this diagonal had a 3 here, you're just going to add 2 because these two match. And so then you update it, and it would be like 5 in that case. But in this case, we're updating from 1 plus 2 to 3. Okay, so I hope that kind of explained it a bit, where there's the cases where first you just fill in this row with all 1s, because it just represents, okay, B and B have a maximum palindromic sequence of 1. Then A compared to A here have 1. B here with B, like they're all 1. So you just initially set it all to 1. And then you say, okay, whenever you encounter something where they don't equal each other, you just take the maximum of what's below it and what's to the left of it. All right? But then when you do encounter a sequence where, okay, these two numbers match, say we're given B, A, A, B, and we're comparing B with it, and you see that these two, this B row, this column match, then you say, all right, so let's take the diagonal of it, say it's this case, and so since this was 2, let's take the diagonal of it, which is whatever's in the middle of the palindrome, and then add 2 to it, which would represent this. Okay, so it's hard to come up with this, like, I think intuitively. You have to do a lot of dynamic programming problems and just trust the process. I came up with some of this code, but I fell short of computing the diagonal. That just didn't come intuitively to me. But doing this sort of like putting the letters like this and comparing it with the column here, that's very common for these dynamic programming problems and building this two-dimensional grid. And just finding a way so that when you traverse this, like you can increment 1 initially, and then look at, okay, given this, these smaller these smaller problems that you solved, how can we add them together to build the bigger problem? That's the whole point of diagonal programming, or dynamic programming. And so then at the very end, your solution is just going to be in the top right-hand corner, which is pretty standard. And it'll just represent, okay, given this entire string now, what is the maximum palindromic string? And you'll just be kind of aggregating it along. So yeah, I hope that helped a little bit. Sorry I didn't just write out the code and explain it step by step. I thought this one was just simpler for me. Plus it's like, literally like I started recording just at the due date. So if we refresh the screen, we're already on the next problem. So yeah, that was today or yesterday's problem now. And why don't we take a peek and see what the next one is? So, it's a hard one. Okay, so yeah, follow me for more. I'll be solving this one probably tomorrow afternoon. So good luck with the rest of your algorithms. Thanks for watching.